The traveling salesman problem. What is it? Focus and optimization. The traveling salesman problem, or TSP, is an algorithmic problem tasked with finding the shortest route between a set of points and locations that must be visited. The origins for this algorithm are actually unclear. A handbook for traveling salesmen from 1832 mentions the problem but contains no mathematical treatment. It wasn't until the 19th century that it was mathematically formulated by two mathematicians, W.R. Hamilton and Thomas Kirkman. First considered mathematically in the 1930s by Merrill M. Flood, who was looking to solve a school bus routing problem, becoming increasingly popular among scientific circles in Europe and the US after a corporation offered prizes for steps in solving the problem during the 1950s and 60s. Our group's interest for this problem is actually because of Amazon. Amazon sales have increased nearly 220% with COVID-19 and made 2 times more money with everything shut down than it did before the pandemic. Their sales were 108.5 billion, up 44% from 2019, with profits rising to a jaw-dropping 8.1 billion. There are a lot of applications and systems that help run Amazon daily, but we wanted to know what algorithm they use for delivering orders or picking up orders from their warehouse. The traveling salesman problem allows Amazon to take a high number of orders and deliver them efficiently and quickly, allowing for the exponential increase in revenue.
So that now that we know, what is the traveling salesman problem, let us try to see what are some ways we can solve the traveling salesman problem. One of the approaches that we can use is the brute force method, which is not an ideal solution because it will take O of n factorial time to actually solve the problem, and we know why it takes such long because it will go through all the possibilities in a graph and then figure out which one is the minimum one, and it will still take O of n factorial minus 1 even if we pick a particular point. Second approach that we used in our code was the dynamic programming. We use top-down DP because it's nothing but just recursion plus the memorization of the recursion tree. So if we have a recursion tree, we're going from point A to B to C and D is our last point. All we have to do is add all the paths and then make an individual path from D to A and then just add them together. That is what I mean by recursion plus memorization. And here it will take O of 2 to the n time, which is not an ideal one, but it is still better than the brute force method. So let us see what we use in our code. We use our Hamiltonian cycle. As we know, output of a traveling salesman problem is going to be the minimum weight of the Hamiltonian cycle. So here in the code we can see the graph. Here the graph is just nothing but all the cities and the distance between them, which is represented as the adjacency matrix. Then we have the traveling salesman function, which takes in the mask, which is nothing but the set of visitor cities, and position, which is from where we're going to travel to the next one. And here you can see this is our output, which is the minimum weight Hamiltonian path cost 80 from this set of cities.
So why is this problem so important? This problem attracted a lot of attention from mathematicians and computer scientists specifically because it is so easy to describe, but yet it's so difficult to solve. The problem can be broken down to what is the least costly route a traveling salesman can take. It is very important because it is known as the NP complete problem, which is crucial because if anyone can find an efficient algorithm for the traveling salesman problem, then other efficient algorithms can be made for other type of problems or for other problems similar that are also NP complete, if that makes sense. Application. So why is the NP problem so important, and why is the traveling salesman problem itself so important? It can be used in many ways, such as logistics, planning, and even manufacturing of microchips. Also, in some cases, it is applied in DNA sequencing. For those applications, instead of thinking about usually you would think of the traveling salesman problem as going from city to city, or a mailman wants to go the least costly route, the most efficient. We could also use other examples like customers, soldering points, or even DNA fragments. For the concept of distance, we could use traveling time or cost along with a measure between DNA fragments. So this is an example of DNA sequencing. So like instead of like, it uses fragments here instead. So conclusion, the traveling salesman problem is one of many NP complete problems. The problem is often concerned with finding the cheapest solution and not necessarily the most effective route. Even with how early this problem was found, it is still a very important problem to understand. This is a little meme. Okay, thank you for your time.